So my name is Andreas. I've been busy on contributing to ZMX over the last couple of months. So nice thing is that most of the ZMX project that Kit was talking about is now moving to ZIO Core as our new metrics API. So, and today it's my pleasure to show a couple of examples and also a couple of nice diagrams and dashboards that come out of that. So my name is Andreas, like Kit just said. So Gies, living in La Vinuela in Spain, so on a beautiful olive farm. And these upon some requests, I've put some pictures of two of my friends. There are 11 in total on our farm. Right, so for the ZIO metrics, so we started as a side project in the ZIO ecosystem. So the idea in ZIO ZMX was to make it easy for ZIO applications to capture metrics throughout a ZIO application and then make it available for querying and particular backends. And the fundamental idea was that the backend should not be dictated by ZMX as such, but the users should be able to actually choose their backend. So we provide how the metrics are captured, and we also provide like how the metrics are encoded for particular backends. But at the end of the day, so we wanted to have a way that the instrumented code wouldn't change depending on the backend you were choosing. So we've done that in ZMX and implemented the reporting to Prometheus and StatsD. And then, as we think that this is like a fundamental requirement for most ZIO applications out there that go into production, so we decided for ZIO 2.0 that the metrics capturing and provide like the API to capture the metrics and collect them and provide them for being queried from for visualization and dashboards should move to the ZIO Core. So, and this is what we have done in ZIO 2. So ZMX still exists. So all the backend implementations, so Prometheus and StatsD currently, are staying in there, and we have started the work on our own client. So the idea behind our own client is we want to give developers like an easy way to look at the metrics they have captured without going through the requirement of setting up a Prometheus and Grafana or a Datadog account or set up an elaborate dashboard environment. So just give them a simple way of looking at the metrics, maybe not as powerful as the other dashboards, but at least you see something. So the way we are doing it, so we have a unified metrics model in ZIO 2. So the metrics model is like we are holding a concurrent state and we have defined an API that's mainly inside the ZIO metric object or inside the ZIO metric package. So any call to actually one of the methods in there would actually modify our concurrent state. So we would modify a counter, a gauge, we would modify a histogram. So this state accumulates over the lifetime of our project. And whenever the user or whenever the application requires to report to one of the backends, so this state is queried or published into the outside world. So, and this is like the same concept. So the same API goes for every backend. So let's have a look at the API as such. So we have defined 5 types of metrics in total, and these 5 types are inspired more or less by the Prometheus definitions of what they support in metrics. So the challenge later on is to kind of map the individual metric types to other backends as well. So Prometheus knows all 5 types, but for example, StatsD doesn't really know all of them. So Where possible, we have defined a mapping, like into the various backends, but we will come to that later on. So what all APIs have in common is we have to kind of define the metric that we want to capture, in this case, a counter. So we do this by calling upon one of the construction methods to define a metric. So in this case, we just define a counter under the name of count and give it some arbitrary labels. And then inside our code, we can use the counter either as an aspect or just by flat mapping it and giving it something, giving it a double value, calling into the increment method, and then the counter would be incremented by the amount that the effect has yielded. So the same goes for gauges. So where the difference between a gauge and a counter is a counter only increases. A gauge can be set to an arbitrary value and it can go up and down. So it just is a reflection like the current memory usage or the current thread count. That would be a good example of a gauge. So again, we would just define our gauge and then we can use it in our instrumented code. So the instrumentation examples are quite simple, but you can measure anything you would want. So the next metric is a histogram. So a histogram in our different, well, a histogram, so this is already where a bit of the problem starts. A histogram for us is a set of counters. So when we see later on, so StatsD, for example, defines a histogram and speaks about quantiles. So we speak of a histogram having, it's a set of counters, and the set is, so each counter is defined by a boundary. So, and if you observe a value with a histogram, so all the buckets are increased by 1 that have a boundary greater than the value observed. So it's very important to note. So you're actually observing a value modifies more than one bucket. So, and our API has helper methods like to set up the boundaries either in a linear way or in an exponential way to make it easier to create like a histogram. So how does it look like? So again, we have like a helper method to create a histogram in our code, and then we just call the observe method within the histogram to observe an arbitrary value, and then the concurrent state behind the scenes is modified according to the rules I've just explained. So then we have another like group, which is the summaries. So the summaries is a collection of samples that is restricted over times or in terms of size. So whether whatever matches first. So for example, you could define a summary saying, I want only the samples for over the last hour or 24 hours, but at most 100 samples, for example. So what the summaries actually give us is an observation for quantiles. So you define like the 10% quantile or the 50% quantile or the 90% quantile. And what a quantile is like, is representing a value, and for the given, and the 90% quantile, for example, is the value within our samples where 90% of the values are less or equal that particular value. So it's a little bit complicated to explain, but for example, if you see a use case for this is like SLA monitoring. So when you want to monitor something like 99% of the requests need to go through in a certain time, so you would build a summary with a 99% quantile, and then you create an alert with the if the value of the quantile exceeds your agreed response time. So this is how it's actually used. So the summary, again, we agree, we define the summary, and we call the observe method on the summary. So now we have captured all these metrics. Oh, sorry, there's one missing. It's a set. The set is missing. The set is just a family of counters where you have like, so for example, within ZIO core, we use that to count how often we have forked a fiber from a line of code. So the token in here would be the location, and the value of the token would be where have we forked a particular fiber. So it would build up a set of counters so that we can exactly see how often did we fork a fiber from these places in our code. So speaking of the ZIO2 provided metrics, so besides like the fiber fork locations, we have defined a couple of others. So for example, the failure courses would be another example for a set. So this would give you so whenever the application or fiber terminates with an exception, so we would capture the class of that particular exception, and we count how often that exception did occur. So that gives you already a hint which exceptions are occurring very frequently and the exceptions which occur only once in a time. So how many fibers we have started, how many fibers have succeeded, how many fibers have failed. So these are all counters. And then also interesting metric is like the fiber lifetime boundaries, so or the fiber lifetimes. So this kind of gives us an impression of how long our fibers are actually executing in our system. Do the majority of fibers execute very rapidly, or do we have quite a number of long-running fibers? So that might be interesting. So, and then based on the work that my colleague David has done, Vigo, we have also all the JVM metrics specified in the Prometheus JMX exporter. So they export all kinds of things like the memory usage, the thread usage of the JVM the application is actually executing in. So then, after we have captured all of these metrics, so we have our concurrent state. So also within the ZIO core, we find the API to actually access the metrics. So, and if we look at the particular backend, so for example, statsd and Prometheus, statsd requires a push-based interface. So whenever a change happens into our metric state, so we need to push the changes to statsd. On the other hand, Prometheus is a pull-based API, so a Prometheus agent expects us to expose an HTTP endpoint that actually presents a text document that has all the metrics summarized. So every now and then, the Prometheus agent would pull that particular HTTP endpoint and understand the metrics that are currently exposed. So the metric client is the way to go. So the metric client has these two methods, unsafe states to get all the states, or unsafe state for a given key to get a particular key. Or it has so this is for the pull-based method, or it has like the metric listener interface that we have implemented for the statsd interface, and we are using it also for our own Scala.js client to provide a WebSocket stream of changes so that they can be looked at. So for the Prometheus, like I just said, so the Prometheus, we need to provide like the Prometheus encoder to our application. So I will show in a minute how we do that. And then we need to kind of incorporate an HTTP server. So, and here we made a decision that we do not want to force the user into a particular HTTP server. So therefore, ZMX only contains like the encoding, but then the users would have to choose either ZIO HTTP as soon as it has a ZIO2 implementation, or at the moment we are using UZ HTTP, or any other HTTP, so any other form of exposing our HTTP document to the outside world would also work. So let me. just show you. So this is the interesting part of the just need to bring up my Prometheus instance and my Grafana instance. And also our server. So may you take a moment what actually is running in the background now. So we have in our ZMX examples, we have an instrumented sample.scala. So it's just a trait that one could mix into a ZIO application just to expose some sample metrics so that we can actually, so it's actually the examples how to use the metrics, how to use the instrumentation code. So this is just like in Scala what you've seen on the slides before. So I think the more interesting stuff is actually the ZMX sample application. And this is more or less all the code that's required to expose our collected metrics to Prometheus. So what you see here is the line 16 to 23. So we actually instantiate our UZ HTTP server. We tell it to serve our Prometheus encoded metrics that gives us a plain text document whenever we make a request on the metrics endpoint. And then in our application, we just do a provide sum, and what we stick in here is the Prometheus client, and you can stick another backend in here as well, but I haven't fired up a statsd instance. So the Prometheus client live kind of connects to the HTTP server and provides all the captured metrics. What you see in line 33 is actually a nice application of the new app API that we have provided with ZIO. So until line 31, I haven't considered any of the JVM metrics. So I'm just using the new API of ZIO2 to kind of mix in a default JVM metrics application that we've defined, so that at the end of the day, so my overall application that's running in the background is what I have defined as a ZMX example, and mixed in the default JVM metrics. So it's now providing all the JVM metrics and my own metrics. So hopefully Grafana wouldn't tell me otherwise. So this is my Grafana instance. And here we have some incoming metrics. So let me make this a little bit bigger up here, because I think this might be the most, so unfortunately the font size is a little bit small, but what you see here is like the representation of our fork location set count. So you see that we have a couple of locations where we actually fork fibers in our app. And what you can see when you represent that as a pie chart, you can kind of see, like, on one glance, the hotspots where the where the forking happens. So which is quite nice. So for the other metrics down here, so you would see, like, the summary is also kind of interesting. So in the examples, we have defined a summary that has had 3 quantiles, so the median, so the 50%, the 90%, and the 10% quantile. And as you would expect, like generating random values between 0 and 500, so the 10% would idle around at roughly 100, the median like in the middle, and the 90% somewhere at 450. So, so this is already giving us a nice insight what's actually happening in our application. And the last one down here, so it's actually, can I make this bigger? Yeah. So it's actually the current memory usage in our application that we have grabbed from the default JVM metrics. All right. So in the code I've shown you, you've seen that we have actually also plugged in the statsd backend. So I'm not going to show it in a live version, but I've actually created a Datadog account for myself, and on another machine at home I installed a Datadog agent that kind of captures the updates, and updates are the dashboard. So in the same, so you can get pretty much the same graphs that we have seen in Grafana, also in Datadog, with the same code. So it's actually the same code without any changes. So last topic is to actually talk a little bit about the developers client we're doing. So like I said, the develop client is really an idea to give a ZIO developer, when he's starting out with ZIO 2, the ability to have a look at the captured metrics without setting up an elaborate dashboard environment. So even if it's easy to set up, but we wanted to make it even easier to actually look at the collected metrics. So what we've done is we create a WebSocket stream of the metric changes, and build an application on top of Laminar. So Laminar, it's a very, very, very good library that's for building UIs with Scala.js. So if you ever try to do something with Scala.js on the browser and you haven't looked at Laminar, take your time to look at it. So for styling, we have used CSS pure frameworks like Tailwind CSS and Daisy UI, so which is giving us CSS-based components for our front end, and also a rather old D3 Scala.js facade that we have upgraded a little bit, and of course ZIO 2. So so where it says demo, let me demo. So I'm going to bring down my Prometheus. Stopping my old server, stopping my Grafana. Starting. So this is a little bit, so I'm using my development version, so therefore, I know I said we want to make it easier to actually look at the metrics, but this is like the development version, so I need to fire up everything from SBT, or then to make it worse, NPM. So give it a moment to finish compiling. So now we have more or less the same instrumentation, instrumented samples up and running in the background. So we can go to our own web server. So it comes up with in a disconnected way. So you can just connect to a WebSocket URL. You can enter up here. So we do connect. It comes up with an empty dashboard. And then we can configure the dashboard and start selecting arbitrary metrics. So it does a discovery of which metrics are actually visible in our application. So then we can start selecting metrics. And it would start rendering the metrics that we have discovered and selected for that particular dashboard as in D3. So actually, so we could so far just split our dashboard into a couple of panels, and then so what's actually not implemented yet is a nice search facilities to restrict the searching within the dialogue, so at the moment you have to read through all the metrics that are being provided for a particular category. So, but I think you're getting the idea of what we're actually trying to achieve here. So what's missing here is capability to actually save the dashboard. So within the dashboard, the nice thing, everything is driven by case classes, config case classes. So it would be quite easy to kind of implement a save button that kind of exports our current configuration of the dashboard into a JSON file so that we can save it and restore it later on. So pretty much as Grafana does with its dashboards. So we haven't implemented like the pie charts or something like that, but we have like implemented a decent, like some way of reconfiguring a graph so I can remove a particular metric from a diagram and then just be done with that, or just go here and modify how many metrics, how many samples I would want to track in my application. So it's getting along. So it's so I hope you would note the difference between what was there and what we have. So this is our vision for the developers client. So whatever ideas you might think are useful to visualizing in here, so please let us know. So this is a really work in progress. Yeah, like I said, so it's more work, so we're looking into more backends. So we have only currently one request open for another backend. So we will need to add more configuration options in our dialog. Maybe a little bit more resizing capabilities. So rather than just doing the horizontal and vertical split. And the protocol that we're actually talking is quite verbose. So there's a lot of potential in kind of getting that optimized as well. Thanks for having me as a speaker. Thanks for the opportunity to be working at Ziverge. If you want to get involved with ZMX, just get in touch. So I try to keep the issues that are currently open fairly up to date. Get in touch if you want to work on one of them, because at the moment there's a lot of things going on in parallel, and it's good to synchronize on who is working on what. Catch up with me if you want to. I'm happy to show the UI code as well, or more pictures of the dogs if that's more interesting.
Awesome job. Thank you, Andreas. So we have at least one question. I think you prematurely answered it, but just to clarify, Nabil wanted to know if you're planning on providing a Grafana dashboard or a Grafana backend. For Grafana?
It was there.
Oh, it was there. It was there, Nabil. Sorry, yeah, I'm not familiar with.
I can show it again as a slide. It was there.
Are you planning or actually already providing? So yes, actually already providing the Grafana one. Nice, and that's got pretty colors.
Yes.
That's a pretty. And then, okay, also, are there plans to add more backends? I think yes, but New Relic, for example.
New Relic is one of the candidates, yes. So, yeah.
All right. So if you desire, if enough people vote for New Relic. And then what about testability? How to unit test whether a counter increased after some API invocation? You don't trust the API designers? You don't trust Andreas?
It compiles, it should work.
But is there any way to test that?
Well, you could probably just write a test with the ZIO test kit, and so the test would involve using the metric client API to kind of to get the state before you increment a counter and afterwards, and measure the difference.
That makes sense, but that's exposed anyway. So, yeah, cool. Maybe some things will come in. But would anyone here like to ask any questions?
So sorry, I missed that bit. So are you saying that the API can also dynamically? Sorry, the API.
I think it'll turn on once. You just need to breathe into it a couple of times. I think they control it up there.
So the API will allow you to interrogate your metrics as you go along, as well as just record.
Yes.
Might just be a pretend thing, but it feels good to hold. It gives you power.
So it's either you query the API and this gives you a map of states, or you implement a listener, so which gives you the updates, a stream of updates.
Oh, and there's a clarification. Yes, I was just trolling you, Nabil, as well before. But you can upload boards to the Grafana homepage and import them via code. That's what he meant.
Oh, okay. So we have an example. So our ZMX code base contains the JSON for the sample dashboard.
Okay, awesome. So yeah, I think now there's just clapping emojis coming in. So I think best clapping emoji in real life, everyone.